Hey everybody, how's it going? I'm hoping you're doing well. Today we're going to be talking about direct variation. So this is somewhat of an intro type of lesson. We did scratch the surface a little bit when we were talking about slopes and rate of change. We're going to look today more closely at how something is a direct variation, how it's not. Y equals kx, very similar to y equals mx plus b. They all kind of tie in, but as I said, this is an introductory type of lesson. It should be very helpful for you, especially in the middle school level. It's always good to refer back to this. So I hope you enjoyed it. I hope it's helpful. Please make sure you subscribe, comment, like, all that stuff will help you make the channel grow. I appreciate it.
All right, so as I said, this is a very introductory type of lesson when it comes to direct variation. It can get rather more intricate as we move on. So the rule of thumb is this. So when we talk about plotting a line or slope, we typically see what's called y equals mx plus b, where this is your slope, the m is your slope, the b is where it crosses the y-intercepts. So this would be your slope, so that could be positive or negative. This would be your y-intercept. So for anything to be a direct variation, you can't have the b here, whether it's plus b, minus b, you just can't have it. So we can have y equals something times x, that's the slope, right? So we want to keep that in mind when we're trying to decide whether something is represents a direct variation, and also when we go to identify what that constant of variation actually is. All right, so first question we're going to answer is y equals 2.5x. Well, if we look, there's nothing here, so this checks out. It's a yes. All right, but and then we have to identify what the constant of variation is. Well, that is the coefficient, which would normally represent, it's k in this case, y equals kx, all right? And then in some cases you may see k equals y over x, or it can be written both ways. So in this case here, our k, and I usually tell kids to indicate that with a k equals 2.5. Now, once again, we go to this one. We want to determine whether it's a direct variation. Well, we have this right here, so it's a big fat no. All right, so we can't go any further than that. This one is a little tough because if we look, the y is not by itself. So we want to divide by 0.8. We're going to do that to both sides. And take note that the coefficient that is with the x is 1. So your new equation is y equals 1 over 0.8x, right? So there's nothing following the x, so it's a yes. And then this would be your direct, or your constant of variation. All right. Okay, now we're more or less going to do what we did before, but we're going to be looking at it from a data set, which is in a graph here. So we want to identify if there's a constant of variation. So remember, k will always equal y over x. So typically, the way I have it set up, at least, if it's not identified, is that the y is going to be on the bottom, okay? So that means you kind of have to invert this. So we have negative 4 over 4, right, y over x, negative 1 over 8, and then 2 over 12. These all should reduce to the same thing. Well, this reduces to negative 1 over 1, this is negative 1 over 8, and this is 1 over 6. So this is going to be a no. We can't even go any further than that. It's a no. All right, this one, price, if you think about when we talked about unit rates, so that's a video you can always go back to. We have, this is representing our y, and this is going to be our x. So k equals y over x. So we have 0.4 over 5, 0.5. All right, then 1.2 over 1.5, and 2 over 2.5. So we actually can get rid of these decimals to make it a little easier. And this is actually 2.0, right? So that's going to end up being 20 when we get rid of the 0 there. All right. So we now have 4 to 5, which is reduced in lowest terms. The 12 to 15 can be reduced to, well, 3 can go into both. That's 4 to 5. And then the last one, 20 over 25, 5 can go into both. That reduces to 4 to 5. So our direct variation, this is a yes, and our direct variation equation is y equals 4 over 5x. All right, so as you can see, it's a bit of a more difficult type of lesson, even though it's an intro. What I would suggest is to definitely look at your slope of a line lesson, which is also, so far we've done an intro one, but they're all going to relate, especially something that you'll see in 8th grade. You can't really escape it in high school, even in those early grades. So you want to have this hammered down, and maybe watch the video a couple times just to see what's taking place there. So we talked about it, just straight computation, and then we also looked at the data set tables. You can see it both ways there. All right, I hope this was a lesson for you that will be helpful. Please make sure to leave a comment, share, and otherwise have a great day.